Good morning, everyone, and welcome to week 8 of Robotic Science and Systems. What I want to talk about this week is the upcoming final project. I've posted the final 3 assignments for the semester. I haven't posted homework 8, that's still going to come up, but I've posted now we have all 4 parts of the final project posted. So the project proposal is due in 2 weeks, and then the project itself is due in about 5 weeks. And at that point, that will be the last thing that you need to submit for the semester. So in the proposal, it says that you are expected to put together a team. You need to pick sort of broadly what you're going to be doing, and then you have to pick a project idea. And then we have the additional requirement for teams with at least 1 grad student is that in implementing your project idea, you need to implement a technique described in an academic paper. You should be able to find an academic paper that describes some robotics technique that's relevant to your project, and then you can do that. So then, after you've submitted the proposal, you're going to work on actually building whatever it is that you want to build, and once you build it all, you'll need to submit 3 things by the end of November. Right, let me double check that. Cal 2020. So yeah, November 30th is when this is due, and you'll need to submit all of your project work by then. You need to complete your project, including the videos that you'll need to do. So the 3 things that you'll need to submit are going to be code, and I don't know exactly what code you're going to need to write for the project. There's probably going to be a robot control program involved in this situation, depending on whether you're doing a Kerbal Space Program thing and you're going to write a bunch of KerboScript, or you're doing a Kerbal Space Program thing and you decide to use the remote interface that lets you sort of control spaceships over the network. Then you'll have whatever language you're using up for that. Or if you're doing a pure gazebo simulation project, you're likely to have a robot control program, like the brain program in the examples, but you're also likely to have additional gazebo plugins that will simulate whatever robot you're building. If you're going to be working with a physical robot kit, which I think a lot of the teams will be, you're going to have robot control programs, but those may come in the form of programs that are running on computers external to the robot, as well as Arduino programs that are going to be running directly on the robot hardware itself. And I'll talk a little bit today about how we can take advantage of the robot kit, which is an Arduino-based kit, so it doesn't let us run terribly powerful programs, but still manage to write sort of arbitrarily complex control programs. Now, so for this portion of the final project, you'll be submitting you'll be submitting this file, and actually you're going to be submitting this file, let me see if I can pop it up here. So you're going to be submitting this file where you're answering a bunch of questions, and actually for all 3 portions of this final project submission, you're going to be submitting the same project and photo text file. You're going to have to submit 3 times because I want to grade you 3 times, and it's easier to do that if you have 3 separate submissions that I can grade. You only have to submit once to each thing for your team, but your team does need to submit 1 separate time for each thing. And so for the code portion, the thing that I'm going to be interested in is your Git repository, which is going to include all the source code for whatever software you've written for the project, as well as the source code or whatever you have for your presentation notes or presentation slides. But for this component, the way this is going to be graded is that the TAs are going to go ahead and grade your submission. And the way they're going to do that is they're going to look at the code quality of what you've submitted, what's in your Git repository, and how much functionality you implemented. And whether one thing is more functionality or another thing is going to be up to the TA's judgment, but it should be like reasonably clear that like if you implemented a complete robot localization system and then mapping and then pathfinding and stuff, that is more functionality that you've implemented than if there's a team that decides that their final project is just to like do wall following in a hallway and have some mechanism to do wall following. Even if it's a slightly complicated method to do wall following, it's still probably going to be less functionality than something with like 5 or 6 complicated components. Now, you're encouraged to use external libraries. You're allowed to use sort of arbitrary third-party code with proper attribution here. And both of these things are a certain amount of functionality that you've successfully implemented it, because integration is implementing functionality. If you stick two things together, you have more than if you didn't stick them together and just had two things. But code that you actually write, functionality that your team implements in fresh code, is going to be worth more on criteria 2 than software integration. If you find a mapping library, that's not as good as writing mapping. So if you've made a serious attempt at submitting something for a project, you're going to get a point on this. And then based on the TA rankings, the top 75% of submissions are going to get 2 points. And then there's an opportunity at a bonus point if you share some example code or code and instructions that are going to be generally useful. And as an example of something that would definitely get a bonus point, at least the first person who does it will get a bonus point. I haven't had the time to really fight with the MBot Ranger robot kit to make it so that I can do communication by Bluetooth from a laptop to the robot kit. The robot kit does do Bluetooth. It definitely does communication by Bluetooth for control with the sample programs that that they've provided with their like basic firmware that comes pre-installed on it. But I haven't been able to replicate that from my Linux laptop. So if somebody can provide a sample firmware for the Arduino and a sample program to run on a computer, really any computer, I'd be most interested in a Linux machine, but if you can get code that runs on your Mac, that might be useful to someone too, that allows you to like send a like drive forward at X speed command over Bluetooth and then a stop command over Bluetooth, or a what does the sonar say request and then get a response over Bluetooth. That would definitely be worth a bonus point. Then what you're going to do is you're going to fill out this project info.txt. It looks like there's 8 questions in here. Here's the bonus point question. And submit it here. Part 2 of the project is going to be a demo. Once you have something working, you're going to go ahead and videotape it succeeding. In the case of a Kerbal or Pure Gazebo thing, that's going to be a sort of screencast kind of situation, like like we've been doing all semester. If it's a physical robot that you're going to be doing, you're going to have to videotape it with like a cell phone camera or a good camera if you have one, or even your laptop camera if you want to hold it goofily. And what I want this demo video to have is a complete run of whatever you're claiming that you do. Sort of start to finish, an example run of the thing that your project is trying to attempt. If you have like a maze solving robot is what you're building, then this should show a full run of solving a maze. This should be in real time. This is something that the TAs are going to want to be able to watch and fast forward and reverse in to see what's going on. Now, if you have some visualization like a mapping window, that should show up in the demo video. If you're doing a like screen capture sort of thing, that's straightforward. If you're working with a physical robot, you're likely to end up with 2 videos. You're going to have your screen capture video and then the video of the physical robot in the real world, and you want to combine those in some way. Editing is going to be the nicest way to do it, but there's some other ideas here. Now, the way this is going to be graded is that if you have a reasonable quality video where like robot-y stuff happens that's like sort of related to what your project is, you're going to get a point. And if the thing that you demonstrate is reasonably challenging, so you're doing something that isn't, I mean, we have to have more than non-trivial. It has to be a little bit difficult to have built. If you did something challenging and the demo works largely as intended, you're going to get 2 points for this thing. Again, you're going to fill out the project info template from the other assignment. I didn't post the template again. In this case, we care a lot about the demo video URL thing, and then that's what you're doing here. For the third part of this thing, you have the presentation. For the presentation assignment, you want to create a presentation video. Now, this presentation video may involve slides, depending on how you do it. It may involve presentation notes, if you have those things, and in some cases you need at least presentation notes to make this make sense, but that material should be in your Git repository. But the video itself should include answers to the following questions. What did you intend to do? What did you have to do to make that happen? What changed about your plan? So you proposed something, and then you did something. How does what you did differ from your proposal? And how did what you did differ from the initial changes you made to your proposal? What software did you have to build, or other components did you have to build in the process? How do those pieces connect together? Which things did you expect to be hard that actually were hard? Which things were hard that you didn't expect to be hard? And how did your demo run go? If you have a grad student on your team, the proposal talked about there being a report. There isn't a report, there's just a presentation. And so here in your presentation, you need to say, what did you implement from an academic paper? Like, what did the academic paper say it was? And then what did you do? What changes were there that you made from the description in the paper? And then if you have slides, you should have a reference to the academic paper there. If you have notes, you should have a reference there. Probably someone who's watching this video should be able to like pause and see what the reference is and go find the paper. The video that you're producing here should be 10 to 15 minutes long. And one of the things that you are expected to do here is put some effort into like composition of this. So this should be, you have the opportunity to make this a little bit more polished than if you were giving a live presentation. I don't want you to spend a ton of time on like editing if you don't need to, or if you don't want to, but it's worth like trying to plan out what you're doing and that sort of thing. Now you could do like full storyboarding on this, film the parts individually and edit them together. That's really nice if you can do that, because it means that you can put video clips from your demo in, or other video clips that you've taken of your project working to illustrate points in the presentation. But a lazier solution, if you want a lazier solution, would be to like get together a video conference, a Zoom meeting or something, of the team members giving pieces of the presentation as if you were giving a live presentation. And then you still want some video clips of your project working, but you could just have someone play that during the thing. Or you could edit them in, but you only have to edit in those few pieces. Now, what should you put in the presentation? Well, you want to answer these questions, but sort of as a general guideline, any time that you can like show your robot, simulated or real, doing stuff, that's going to be better than showing like UML diagrams that sort of abstractly talk about the structure of your program. Sort of quick diagrams are frequently useful, but formal diagrams, if you can leave them out, that's great. Being able to quickly describe a neat algorithm and how you implemented it, that's great content too. And both the demo videos and the presentation videos and your Git repositories are going to be available to the class, so don't put any like super identity theft secrets in there that you're not expecting. So how will this be graded? This one's going to be graded a little bit differently from everything else in the semester. The 2 points that this is worth are going to be evaluated separately. Point 1 is going to be figured out by me, and I'm going to look at your presentation and look at the other stuff that you've submitted, and I'm going to try to figure out, did you make a serious attempt at doing something that I think is an interesting robotics project? There's some subjectivity there, but I'm going to interpret interesting relatively broadly. You'll know if you did something that was super boring, like that wall follow example I talked about earlier. Unless the wall follow is crazy computer vision, and then it might be interesting. And then, did you present it well? And if you did those 2 things, you get the point that I'm going to give you for this. The other point is going to be dependent on what other students think of your presentation. So everybody's going to be expected to watch all of the presentation videos. I don't know if we'll be able to sort of synchronize that with class meetings for Q&A. We're definitely going to use at least the last 2 course meetings for Q&A. We may use the last 3. But when people will watch the videos, I don't know. But everyone will be expected to watch all of the videos. I don't think we'll have that many teams. We don't have that many students, and teams are relatively big. Still, there's probably going to be more than an hour of presentation videos. There might be more than 2 hours of presentation videos. We'll see. But everyone's going to be expected to watch all the presentation videos and then fill out a form rating and or ranking both the projects and the presentations based on the presentations. And if you end up in the top 75% based on those rankings, you're going to get the second point. If you end up in the bottom 25%, you don't get the second point. You do get to rate yourself, and you're expected to vote that you are the greatest project ever. And since everybody's going to do that, that will be fair. But your vote only counts if you rate everyone else too. So that's the motivation to actually do the rating. We'll have some Q&A for the last couple classes. We'll have at least a Q&A thread on Piazza, and so the Q&A will happen before these ratings are due. So again, you submit your project info.txt here. You're just creating one, and then your team submits it 3 times, and that is the general story on the project. So in addition to the general story on the project, the other thing that I wanted to talk about today is project ideas. And I'm going to start off in this video just talking about Kerbal Space Program project ideas. There aren't that many great projects that I can think of for Kerbal Space Program, but 3 ideas that might be worthwhile are being able to automate a mining mission to Tylo. That's one of the moons of Joule. It's sort of annoying to land on manually, and it requires a little bit of mission planning to have enough resources to get it done. But having sort of automation for doing the sort of individual pieces of the mission, not necessarily the overall mission plan, that's going to be basically the same. We get into orbit, we do a transfer to Kerbin to Joule, then we do a transfer into Tylo orbit, then we land, then we mine, then we go back into orbit, and then we go to wherever we're going. But the individual steps, you can do some automation there, and it might be, you might be able to get it so that it's a interesting thing to do, especially since that particular mission requires a relatively complex ship, which might result in a lot of automation. And we have to do the mining step, which requires some thought. The next idea is to do the sort of most difficult manual mission that you commonly see in Kerbal Space Program fully automated. And that is to land and take off from Eve. Eve has a super thick atmosphere that makes the takeoff step take a ton of fuel, and to a large extent, this is a question of pre-planning, but this is a difficult enough pre-planning problem, and it may require some altitude-based stuff rather than timing-based stuff, and planning such that if this is what you go with, it'll probably manage to be interesting enough. Another project that I think might be interesting is a general transfer script. And the idea is we want to be able to do transfers between two bodies with in the same parent that can handle finding a burn that will deal with inclination changes or deal with mismatched inclinations effectively. And this is a case where using search might help. And that's a relatively simple problem that doesn't look like it's that much more difficult than the homework where we were doing tours. But in fact, it's not more difficult than the sort of best case of the homework that we were doing tours. But if you thought that tour homework was fun and want to work with a team of like 3 people for a month on it, I think there's 3 people in a month worth of work. And if you want to do that as your project, have fun. Just make sure that you manage to produce something that does end up being interesting and does require sort of non-trivial code to make it work. The other thing that's useful to consider with KSP is that we used a lot of KOS, but there is another mod for KSP, and I'm actually going to Google it live here. So there's a post here about controlling KRPC. So there's this KRPC thing that allows us to control a Kerbal Space Program from scripts running outside of the game. This goes over a network connection. So conceptually, you can run an arbitrary programming language, and there's clients available for a bunch of stuff. And this is an alternative to using KerboScript to write KSP control programs. I haven't spent any time with KRPC, but it might be an interesting thing to look at for the project. All right, so that's what I have for ideas for Kerbal Space Program. It's probably the least interesting of the 3 options, with the other 2 options being pure gazebo and working with a physical robot. But it's one of the options, and if you want to do it, I'm sure you can have a lot of fun and learn a bunch of stuff.